Okay, in this video I will demonstrate the graphical technique of linear convolution method. So first, what is linear convolution? Linear convolution is a technique to compute LTI system output while the input sequence of the LTI system and the impulse response of the LTI systems is given. Now, what this parameter LX, IX, LH, IH, etc. right? So xn is the input sequence where the length of the xn is LX and the starting index of input sequence is IX. Similarly, LH is the length of HN sequence and IH is the starting index of the impulse response sequence. So if these four parameters are known, we can simply calculate the length of the output sequence by this expression and starting index of the output sequence by this expression. And this is the analytical expression to compute the LTI system output through linear convolution. And this linear convolution is commutative. That means if we interchange these functions, the answer will remain same. Okay. Now, to consider the graphical techniques, I'm just taking this example of xn and hn. Xn is a sequence 1, 2, 1, minus 1. There are 4 sample points, that's why Lx equals to 4, length of the xn sequence. And the starting index of this xn corresponds to this particular term, and this term appears at n equals to 0. Because there is no arrow below any one of the term, that means the first sample point corresponds to n equals to 0. And the picture shows the signal itself, xn. For n equals to 0, the value is 1. For n equals to 1, the value is 2. For n equals to 2, the value is 1. For n equals to 3, the value is minus 1. That means starting index is basically 0 of the sequence xn. Similarly, hn has 3 elements or 3 sample points, that's why LH equals to 3, and the starting index is 0. So we can observe the speciality of these two signals is that both the signals are causal and both the signals are of finite durations. Therefore, the output signal would be finite duration, because if any one of the signal sequence is of infinite duration, this value would appears to be infinity. Okay, therefore the graphical technique is suitable for in such a case where both the sequences xn and hn are finite durations, otherwise you can't solve it. And this IY starting index is equals to 0 plus 0 equals to 0. That means there are 6 sample points and the starting index of the yn is 0. Now let's take a look of a basic idea of signal time domain reflection. Okay, xk is a signal, sorry, hk is a signal where k is a dummy variable. This is basically the time index, and it was 1, minus 1, 1. Now h of minus k would be the reflection of these signals along the vertical axis. So this one appears here, this minus 1 now goes here, this one now appears at the minus 2. And now if we just verify through functional modeling, that means h of minus 1, that means minus of minus 1 means plus 1. So what is the value of h of plus 1? You get it from the picture. Its value is minus 1. That's why this minus 1 appears here. So at this particular value, k equals to minus 2. So minus of minus 2 means 2. That is h of 2. What is the value of h of 2 from the signal given to you? 1. That's why this one appears, this particular one appears here. Okay. Now the graphical method. What are the steps we will follow? Basically, it's very simple technique. First, calculate the length of the output sequence. Next, calculate the starting index value of the output sequence. And now start taking the value of n with the starting index value of the output sequence. Here in this case it is 0, so I'm putting n equals to 0. Okay, so if we put n equals to 0 in this particular analytical expression, it takes a form y0 equals to the right hand side. So this portion is basically, we are not interested in this graphical technique analysis, because this technique is useful or required for analytical method. Okay, that is another technique. I'm not going to discuss this one here. Just we can directly write down the values. What is the technique? Just take a look. For graphical technique, you just draw this x of k and draw this h of minus k. Just look at the picture. Just look at the picture. And for n equals to 0, this function is xk. So first draw this xk signal, and now this function becomes h of minus k because n equals to 0, and draw h of minus k in the same time scale. That means this k equals to here and k equals to 0 means you align k equals to 0 for both the functions. Now if we do that, now find out which of the samples are in common intersections. Just consider these two samples, these samples. Okay, here we can see for k equals to 0, this sample and this sample are in common intersections. So multiply these two samples, 1 into 1, that's why 1 into 1. And we can see for this particular case, there is no more samples which are in common intersection. These are appearing in the negative side, these are appearing in the right hand side. So only one term will be there in the summation, and that also can be reflected from this analytical expression. Okay, so that is different aspect of analytical solution of LTI system output through linear convolutions. I'm not going to discuss these things here. So how many terms? Only one term, 1 into 1, its value is 1. That means we found our first output sample y0, that is 1. Okay, next, now y1. So for y1 we have to put n equals to 1. So if we put n equals to 1 here, that means we have to draw xk. Just below that we have to draw h1 minus k. So what is h1 minus k? As you can see, this is the signal h minus k. So h1 minus k means this signal will be shifted right side by one sample point. If we do that, as you can see, this sequence has, earlier sequence has been now right shifted by one sample point. Okay, so now here we can see there are two sample points which are in common intersection. So this one is common to this minus 1 because both of them are appearing at k equals to 0. That means 1 into minus 1, that's why 1 into minus 1, plus this 2 into this 1, that means 2 into 1. So if we solve, that would give me 1. That means we find that y1 equals to 1. That means earlier we found y0 equals to 1, now we found y1 equals to 1. We have found two sample points. Rest of the 4 sample point we will keep on doing this way. Let me go to the next slide. Yes, here n equals to 2. If we put n equals to 2, we have to draw h2 minus k. That means one more sample right shifted. Okay, so now how many number of samples are there in the common intersection? 0, 1 and 2. As you can see, 0, 1 and 2. For these k values, the samples are in common intersection. So in this particular case, we have 3 terms. Okay, so first term we'll consider 1 into 1, that's why 1 into 1, plus 2 into minus 1, that's why 2 into minus 1, plus 1 into 1, that is 1 into 1. So if we just solve it, that means 2 minus 2 equals to 0. That means my third sample point, the output is equals to 0. So we are not basically calculating from here. We can directly look at the picture and write down this right hand side expression. So this is the things. So in case of analytical solutions, we had to do all these summations, right, and get the function values for these particular samples and put it there, you will get this one, correct? But now in graphical technique, instead of writing this equation, from this equation we can draw this particular sequence xn and h of corresponding n minus k terms, okay, one after another one, and just find out the common intersections. Directly we can write down this right hand side, okay, sum of product terms, and that would give me the final output. Next, for n equals to 3, so shifted one more sample right side. Now here again for k equals to 1, 2 and 3, the samples are in common intersection. So first term will be 2 into 1, that's why 2 into 1, plus 1 into minus 1, that's why 1 into minus 1. Next term is minus 1 into 1, that's minus 1 into 1, that means minus 1 minus 1 minus 2 plus 2 equals to 0. That means my fourth sample point is 0. Now for n equals to 4, one more shift to the right side. Here common intersection corresponds to k equals to 2 and k equals to 3. As you can see, this sample point and these sample points are in common intersections. So there will be 2 terms in sum of product, 1 into 1, that means 1 into 1, plus minus 1 into minus 1, that's why it is minus 1 into minus 1, and the output is 2. That means my fifth sample point is 2. Now go to the last one. For n equals to 5, one more shift right. So now what is this common intersection? Only one sample, minus 1 into 1, that means only one term, minus 1 into 1, minus 1 is the answer, right? So we found 6 sample points and we started n equals to 0. So we can stop our algorithm here, and that is the final answer. So in this way we can find out the linear convolution answer through graphical technique.